There are numerous such tasks in daily life that are totally disrupted when their order is changed. For example, in language, the sequence of words defines their meaning. In time series data, times defines the occurrence of event. And in genomic sequence data, each sequence has a different meaning. There are numerous examples of this where the sequence data influence the event itself. If we want to use such data for any useful output, we need a network that has prior knowledge of the input to fully interpret it. Thus, recurrent neural network comes into play, RNN. So, hello everyone, I am Mayank and welcome to Simplilearn. Today, we will take you through a hands-off lab demo of how we can use RNN model for sentiment analysis in machine learning. So let me tell you guys that we have regular updates on multiple technologies. If you are a tech geek on a continuous hunt for the latest technological trends, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. Great, I think we can get started. So in today's session, we will discuss what RNN model is. Moving ahead, we will see why should we use RNN. After that, we will see how does RNN work, recurrent neural network. After covering these topics, we will move forward and see types of RNN, recurrent neural network, and applications of RNN. At the end, we will do a hands-off live demo of sentiment analysis. So before starting, let us have a simple question to brush up our knowledge. So question is, what are the application of RNN? Okay, NLP, time series, image captioning, and all of the above. Please answer in the comment section below and we will update the correct answer in the pinned comments, or you can pause this video, give it a thought and answer in the comment section. Before we move on to the programming part, let's discuss what RNN is and proceed further for the same. So what is RNN? Recurrent Neural Network. So RNN work on the principle of saving output on a particular layer and feeding this back to the input in order to predict the output of the layer. This is how can convert a feed neural network into a recurrent neural network, RNN. The node in different layers of neural network are compressed to form a single layer of recurrent neural network. A, B, and C are the parameters of neural network. Now that you understand what RNN is, let's look at the way why RNN. Okay, so why RNN? RNN were created because there are few issues in the feed forward neural network. Cannot handle the sequential data, considers only the current input, cannot memorize previous input. Okay, so the solution of these issues is RNN. And RNN can handle sequential data, accepting the current input data and previously received input data. So RNN can memorize previous input due to their internal memory. So moving forward, let's see how does RNN networks work. Okay, so the input layer X takes an input to the neural network and processes it and passes it into the middle layer. The middle layer H can consist of multiple hidden layers, each with its own activation function and weight and biases. If you have a neural network where the various parameters of different hidden layers are not affected by the previous layer, that is, the neural network does not have the memory, then you can use RNN. So the RNN will standardize the different activation function and weights and biases so that each hidden layer has the same parameter. Then instead of creating multiple hidden layers, it will create one and loop over it as many times it has required. So moving forward, let's see types of RNN. So there are four types of RNN: one to one to many, and many to one. So let's see one-to-one RNN. So this type of neural network is known as the vanilla neural network. It is used for general machine learning problem which has a single input and a single output. Now see one-to-many RNN. This type of neural network has a single input and multiple outputs. An example of this is the image captioning. Now let's see many-to-one RNN. This RNN take a sequence of input and generates a single output. Sentiment analysis is a good example of this kind of neural network, where a given sentence can be classified as expressing positive or negative sentiment. And the last one is many-to-many RNN. This RNN takes a sequence of inputs and generates a sequence of output. Machine translation is the one of the example. So moving forward, let's see application of recurrent neural network. First one is image captioning. RNNs are used to caption an image by analyzing the activities present. The second one is time series prediction. Any time series problem like predicting the prices of stocks in a particular month can be solved using RNN. And the third one is natural language processing. Text mining and sentiment analysis can be carried out using RNN for NLP, natural language processing. The fourth one is machine translation. Given an input in one language, RNNs can be used to translate the input into different language as output. So now let's move to the programming part. First, we will import some libraries, major libraries. For the first, we will import for the data frame. So I will write import pandas pd. The second one is import numpy as np. So pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers a data structure and operations for manipulating numerical tables and the time series. And this NumPy. NumPy is a library for the Python programming language, adding support to four large multi-dimensional array and matrices, along with a large collection of high-level mathematical function to operate on these arrays. Okay, so for plotting, we will import some libraries like Seaborn as SNS. This is nothing, just a short form of, we don't have to write again and again Seaborn. We can write SNS. So then another one is from what cloud port what cloud. Port matplotlib dot pyplot as plt. Okay, so Seaborn is a library that uses matplotlib underneath to plot graphs. It will be used to visualize random distribution, and the word cloud is a visual representation of words. Cloud creators are used to highlight popular words and phrases based on frequency and relevance. They provide you with quick and simple visual insights that can lead to more in-depth analysis. And this matplotlib. Matplotlib is a plotting library for the Python programming language and its numerical mathematical extension NumPy. It provides an object-oriented API for embedding plots into application using general purpose UI. Okay, like Tinker, WXPython, Qt, or GTK. So let's import some NLTK, Natural Language Toolkit. So I will write import NLTK. Okay, from NLTK dot stem import word net lematizer. Then from NLTK dot corpus import top words. Then from NLTK dot tokenize port word tokenize. So NLTK, the Natural Language Toolkit, or more commonly NLTK, is a suite of libraries and programs for symbolic and statical natural language processing for English written in Python programming language. And this is stop words. Stop words are words that are so common they are basically ignored by typical tokenizers. And this word tokenize is a function in Python that splits a given sentence into words using the NLTK library. Okay, so let's import some scikit-learn library. So for that, I will write from sklearn dot model collection import train test splits. Okay, then from sklearn dot feature extraction dot text import FID vectorizer. Then from sklearn dot matrices matrix import confusion metric classification. Okay, so scikit-learn is a free source software machine learning library for Python programming language. It features various classification, regression, and clustering algorithms, including support vector machine learning, logistic regression, and many others like random forest classifier. And this train test split method is used to split our data into train and test set. First, we need to divide our data into features like x and y labels. And this TF-ID vectorizer converts a collection of raw documents into a matrix of TF or IDF features. The fast text on what to vectorizer, what embedding Python implementation. And this confusion matrix. A confusion matrix is a table that is used to define the performance of a classification algorithm. Okay, then we'll import some libraries like from sklearn dot linear model port logistic regression. So then from sklearn dot pm port, then from sklearn dot symbol port random forest classifier. Okay, then from sklearn dot naive port Bernoulli base. Okay, so everything is correct. We will see while running. So logistic regression estimate the probability of an event occurring, such as voted or didn't vote, based on a given dataset of the independent variable. Here SVC, logistic regression estimate, sorry, linear support vector machine, SVC is an algorithm that attempts to find a hyperplane to maximize the distance between classified samples. And this random forest classifier creates a set of decision trees from a randomly selected subset of the training set. And this Bernoulli NB. Bernoulli naive Bayes is a part of the naive Bayes family. It is based on Bernoulli distribution and accept only binary values that is 0 or 1. So let's import some TensorFlow. So import TensorFlow dot compat dot v2 and then import TensorFlow datasets as TFDS. So TensorFlow is a free and open source library for machine learning and artificial intelligence across a range of tasks, but has a particular focus on training and inference of deep neural networks. Okay, let's import warnings. Nothing warning. The warnings. Import RE and import string import pickle. So everything is basic. Just let's see the pickle. Pickle is a Python is primarily used in serializing and deserializing a Python object structure. Okay, let's run it. Let's see how many error can come. After that, we will load the data set and we will go through data visualization. Okay, word cloud cannot import name word cloud. Okay, C will be capital here. Random forest class. Okay, it's still loading here. Let's see. Okay, so loading is done. So now let's load the data set. So we'll write data equals to pd dot read underscore csv dataset name test one. So you can find this dataset on the description box below. Coding equals to Latin equals to polarity. Okay. ID comma date comma query. Perhaps you forgot comma where equals to polarity. Okay, yeah. Seems fine. Let me change this first. Is using RNN. Okay. So here I will write data equals to data dot sample equals to one data. Okay. So let me like brief tell you that what we are going to, okay. Let me brief you like what we will do in this sentiment analysis using RNN. So in this demo, like you will see text processing on Twitter dataset, and after that we will perform different machine learning algorithms on the data such as logistic regression, random forest classifier, SVC, naive Bayes to classify positive and negative tweets. After that, I will also build a RNN recurrent neural network, which is the best fit for such textual sentiment analysis. Okay, since it's a sequential data set, which is requirement for the RNN network. So let's dive into. So now we will see the data visualization, data set details target like the polarity of the tweets, zero negative. Okay, then the date, like date of the tweet and the polarity and the user that what tweeted, then the text. Okay, so I will write print data set shape data comma shape. Okay, wait, let me first do like this. Yeah. So there are 20, or you can say 2 lakh rows and 6 number of columns. Okay, so it is a huge data. I will, you can find this data set from the description box below. So here, let's see the data. And why I use head. Head is used for like for showing top 10 rows of the dataset. If you will use tail instead of head, it will show the last 10 rows of the dataset. Okay. Here polarity 0. 0 means negative and 4 means positive. Okay. Like you can consider as 0, 1. This is ID, date, then query, then user, then the text. Okay. So here I will do data, polarity, dot. Okay. These are the 0, 4. Okay. Uniqueness. 0 means negative and the 4 means positive. Yeah, replacing the value 4 as 1 for the ease of understanding what I said to you, you can consider as 0, 1. So data, polarity equals to data, polarity, 4 to 1. And then data. So now you can see 0, 1, 0, 1, 0, 1, 1, 0. Okay. So if you will write only head, it will show the top 5 rows only. Okay. So now let's use one Python function describe. So data dot type. So as you can see here, count is 2 lakh and the mean of the particular row is this and the ID is this standard deviation, minimum value, the 25%, the 50% and the 75% and the maximum. Okay. So let's see the number of positive versus negative tagged sentence. Okay. So here I will write positives equals to data, polarity, data dot polarity was equals to 1, then negatives, data, polarity, data dot polarity is equals to 0. Print total length of the data is dot format data dot shape. Now I will print the total length, the negative and the positives. Okay, so number of positive. Okay, dot format of positives. So I will copy this and paste it here. And here I will do the changes for the negatives. Okay, now let's see. So here polarity is not defined. Comma. So as you can see, the total length of the data is 2 lakh and the number of positive sentences is like 1 lakh 46. And number of negatives, okay, spelling is the number of negative text sentences 99,954. Okay, so now we have a brief data. So now let's get a word count per of text. So for this, I will write count and words done length of words dot split. Okay. And now let's plot a word count distribution for both positive and negative. So I will create a bar plot. So for that, I will write it word count to data and text dot apply word count. Okay, then I will write p positive equals to data, then count data dot polarity is equals to 1. Then so let me copy this only. Here I will write 0 and okay, then plt dot figure and figure size equals to 12 comma 6. Okay. Then plt dot 45, then plt dot x label word count, plt dot y label and frequency. Then we'll write g equals to plt dot comma n color equals to alpha equals to 0.5 positive. Okay, then let's make a legend also. Location should be Right. False. Where data word count priority equals to. Okay, my bad. So as you can see the positive and the negatives. Okay. So these are the like word count distribution for both positive and negative. Okay. So now let's what we can do, we can do the get the common words in training data set for the training data set. So for that I will do from collections import counter all words equals to, and for and test data text equals to line dot split for word and words if length of word greater than 2 all words dot append word dot lower. Here I can write counter all words dot most common, then I need 20. So as you can see, these are the most common word used like in every sentence. The and you for have that I am but just like this out over all. So these are the most common words like it used the is used like 64,000 times and like this. Your is used for 8,000 times, something like that. So now we will do some data processing. Okay. Now let's do the data processing. So live and SNS dot count plot data polarity. Okay, these are the negatives and its positives. There is a slight change, I guess. That is why it's not looking so much of different. Like there's a slight 46 different, so that is why it's looking almost same. Okay. So now removing the unnecessary columns like query, user, word count, data dot drop date query and word count. X is equals to 1, comma, place equals to true. Okay. Okay, it will be true. So here I will write data. Word count is no, okay, my bad. So here I will write data dot drop ID, comma x equals to 1. So then data dot head the data. See, we have only the two, the polarity and the text. Okay. So now let's see the null values. So data dot um, data print. Okay. So there is no null values. So now converting pandas object to a string type. For that we have to write text equals to data text type. Yeah. Object as types. Yeah. So now download the stop words NLTK dot download words words also set stop words it's in English. Print stop words. This these are some stop words. So moving forward, let's download NLTK dot download the NLTK dot download what net. So the pre-processing steps taken are like lower casting, each text is converted to lowercase. Then remover of URLs will do this. Matlab, we will do. Okay. Links starting with HTTP or HTTPS or www are replaced by like commas. Removing usernames, removing short words, removing stop words. Like lemmatization is the process will do of for the converting a word to its base. Okay. So for that, what I will do, I'll just copy the whole code for you. I will explain you one by one what I've done. Okay. So this is a course for the URL pattern for removing all the www, HTTPS and HTTP type of thing and removing them. And I have used pattern for the lower casting, removing all the URL. Okay. Then removing all the usernames like at the rate and removing punctuations and stop words. Okay, like this. So now what we have to do, data P the processed tweets, then data text dot apply lambda x process, then tweets, okay, then print text pre-processing. So it is taking time. And it will be completed. It will return here. The text pre-processing is done. Okay. So as you can see, the text pre-processing is done. So now let's check data dot add done. As you can see the at the rate and this slashes are gone. Okay. So now the text is pre-processed. So now what we will do, we will analyze the data. So now we are going to analyze the pre-processed data to get an understanding of it. We will plot word clouds for positive and negative tweets from our data set and see which what occurs the most. Okay. First we will create for the negative words or negative tweets you can say. So I will add plt dot figure, then figure size 15 comma 15. Okay. Then word cloud equals to word cloud max words equals to 2000 comma width equals to 1600 comma height equals to 800 and rate dot join the data dot polarity, and I will write here polarity, okay, equals to 0, again, then processed tweets. Okay. Then here I have to write plt dot show may show wc interpolation equals to bilinear. Okay, perhaps you forget the comma here. So 2000, then comma width dot generate. Okay, what I can do? Let me run now. Let's see. Hope this time it will work. Okay, it's still loading. As you can see, this is it's okay. Like today, I am and work, don't wish, they need much. These are the most negative tweets. Okay, words from negative tweets, you can say, right? So let's see the positive tweets. Okay, so the thing will be same. Let me copy, paste it here. So for this, I will do one. It will take little bit of time to come. Still loading. Like as you can see, hate, can't. Okay, sorry. These are the negative words. Okay, still loading. So let's wait for like few seconds. Now you can see the positive words like love, okay, good, lol, and awesome, something like that. Okay, so these are some positive words. So now let's do the vectorization and splitting the data, like storing into input variable process tweets to X and output variable polarity to Y. Okay, we'll do that. So X equals to data processed tweets values and Y equals to data identity dot values. Okay, now I will write here print x dot shape print y dot shape. Okay, cool. So now what we will do, we will convert text to word frequency vectors. Okay, TF to IDF. So this is an acronym that stands for term frequency to inverse document frequency, which are the components of the resulting scores assigned to each word. Okay, so term frequency, this summarizes how often a given word appears within a document. And inverse document frequency, this downscales word that appear a lot across documents. Okay, so now here we will convert a collection of raw documents to a matrix of TF to IDF features. Okay, then I will write vector equals to TF vectorizer and sublinear x equals to vector dot fit transform and print fitted. Okay. Print number of feature, comma length vector dot get their names. So number of feature words are like 170321. Okay, now we will do like let's print the shape. Yeah. So now we will do the split to train and test. So the preprocessed data is divided into two sets of data, training data and the testing data. So data set upon which the model would be trained on contains 80% data. And the test data is the data set upon which model would be tested again contains 20% of data. So for that I will write x train test, comma y train, comma train test by test size equals to 0.20, random state equals to 101. Okay, random state. So what I will do the print the shape of X train, Y train, X test, Y test. Like how many columns are there, rows? Not column exactly, the rows are there. Okay. So I will paste there. So see, X train like this is a total was like 2 lakh. Okay. So 1,60,000 in training, as we discussed earlier, like 80% in training and 20% in testing. Okay. So now let's do the model building. Okay, model evaluating functions. So now let's make a model. Okay, and first I will write and then I will explain you the whole. Okay, so here what I did it, this will tell you the accuracy of the model of training data and the testing data. Okay, then we will predict the values for test data set and the evaluation for the data set. Then we will compute and plot the confusion matrix. Okay, the both the categories negative positives. Okay, group name will be true negative and the false positive. Okay, so this is the thing. That's let's run it. So now what we will do first for the logistic regression. So here I will write LG equals to logistic regression. Okay, then history equals to LG dot fit X train, comma Y train. Okay, then model evaluate LG. Now let's see. This is for the logistic regression. Okay, as you can see, the accuracy of the training data is 83%, the testing data is 77%. Okay, so this is the confidence matrix, the predictive value. Like these are the categories. Now let's see for the linear SVM. For that, I will write SVM equals to SVC and SVM dot fit train comma y train and model evaluate of SVM. Okay, and after that we will do for random forest and the naive Bayes. Okay, then we will start with the RNN. So as you can see, the accuracy of training data is very pretty good, 93%, and registration is 83%, and the testing is less than regression model. Let's see for the random forest. So I will write here RF equals to random forest classifier estimators equals to 20 criterion equals to entropy more than max depth equals to 50. Then RF dot fit X train comma Y train and model evaluate. Okay, loading. Let's see the accuracy how it will come. After this, we will do for the naive Bayes, and after that, we will move on to the our main model RNN, recurrent neural networks. Still loading. Yes, it will take little bit of time. So as you can see, the confusion matrix. Okay. So training data accuracy is 75% is very less. So now let's see the last model name base. Okay. So NB equals to Bernoulli NB NB dot fit Spain comma Y train. Okay. Then model evaluate. So name base training 86 76. So as far linear SCC has the best test training accuracy you can say, and the best testing accuracy is 76 70 76.45 77. See logistic regression. So now let's move to the our main model RNN. So what is RNN? Recurrent neural network al- are the state of the art algorithm for sequential data and are used by Apple Siri and Google Search Voice. It is the first algorithm that remembers its input due to an internal memory, which makes it perfectly suited for machine learning problems that involve sequential data. And there is one more thing, embedding layer. Embedding layer is one of the available layers in Keras. This is mainly used in natural language processing related applications such as language modeling, but it can also be used with other tasks that involve neural networks. While dealing with NLP problems, we can use pre-trained word embeddings such as GLOW. Alternatively, we can also train our own embeddings using Keras embedding layer. LSTM layer, long short term memory networks, usually called LSTMs. I have made already many videos, you can check it out, were introduced by Skymeter. These have widely been used for speech recognition, language processing, sentiment analysis, and text prediction. If you are going deep into LSTM, we should first understand the need of LSTM, which can be explained by the drawback of practical use of RNN. So let's start with RNN. Okay, so here I will importing some libraries. Okay, so after that I will write import keras version 2.110. Okay, fine. So now let's print x test comma y train y test equals to train test with tweets comma data dot polarity dot values, then test size equals to 0.2. Test size 0.2 means like 80 and 20% thing, 80 to training and the 20% to testing. Okay. Then let's the model evaluation. Okay. So I will. These are ReLU, sigmoid, all the the layers. So now this epoch, it will run till 5,000. Like count will go till 5,000. Okay. See the 5,000 and it will go to 1 to 10. So it will take time. So I will get back to you after this, completing this. Okay. Now as you can see, the box ran successfully. Okay. So what should I do? For I will give some space here. So now we will see the positive and negative outcome. Okay. This is something like testing. Okay. We will test. We will predict. We will give one a sentence and then we will predict it is coming right or wrong. The accuracy is giving a right or wrong. Okay. So here I will write sequence equals to tokenizer dot text to sequences. Okay. Then I will write this data science article is worst. Okay. So here I will write test equals to pad sequences, and here I will write sequence comma max length equals to max length. Then I will write here prediction equals to model. We will write model, then we'll write model 12 2 dot predict, then test. Okay. If prediction is greater than 0.5 means 50%, then it should print positive. Okay. Else negative. Okay, let me run this. Okay, sequential object has no. Okay, spell mistake. See, the negative because here is the word worst. It is showing correct. Now check from the RNN model. So model equals to keras dot models dot load models. Here we will load RNN model. RNN underscore model dot sdf file. It is pre-trained model. Okay, pre-trained RNN model. So sequence equals to tokenizer dot text to sequences. Then I will write here this this ML course is best. Okay, best equals to pad underscore sequences sequence max length x underscore length. Okay, then prediction equals to model dot predict, then test if prediction is greater than 0.5 and positive. 0.5 means 50%, more than 50%. Else print negative. Attribute load models. Be positive because this ML course is best. So there is no negative word. Okay. So what we will do now, we will do model saving, loading, and prediction. Okay. So for that, I will write import pickle file equals to open vectorizer pickle, then wb. Okay. And here I will write pickle dot dump vector file vector goes. Okay. So like this, I have to write for naive Bayes, logistic regression, SVM, and random forest. So what I will do, right here. Okay, let's run this. Okay. So now what we have to do, we have to predict using saved model. Okay. What we will do here, we will load model first and we will predict. Okay. So first I will write the function name load models And we will load the vectorizer. So file equals to open vectorizer dot pickle rb and vectorizer equals pickle load file, the file dot close. Now I am loading the logistic regression model. So for that we have to write open b lg equals to pickle load file, that file dot close, then run riser lg. Okay, run it. Yeah. So now we will predict the sentiment. So for that I will write df predict riser comma text. Okay. So here we will predict the sentiment. So for that, this is underscore text equals to process underscore sentiments for sentiment in text. Then text data vectorizer dot transform. This is underscore. Then sentiment to model dot predict data. So here I will make a list of text with sentiments. So for that I will add data equals to empty array. Then for text prediction and zip text comma sentiment data dot append text comma prediction. Okay. Then we will convert the list into pandas data frames. So for that I will add df equals to pd dot data frame comma columns equals to text comma sentiment. Okay. Then df equals to df dot replace comma 1 negative comma positive. And df. Okay. So at last I will write here if equals to then here we will loading the model vectorizer comma lg equals to load. Here we text to classify like what should be in the list. So like text equals to, here I will like I love machine learning. So John, I feel so. Okay. So here df equals to predict vectorizer g comma text, then print df dot head. See, I love machine learning positive, Perk is so active positive, John I feel so good negative. Okay, there is at, yeah, see, that's coming. Okay, so this is how you can do the sentiment analysis using RNN model. Here we have loaded RNN model. So it is showing right. So let's do them as goes is right here at boy. Negative. Okay. RNN model is working. So right. Okay. So I hope you enjoyed this video till here. If you enjoyed this video, please subscribe to our YouTube channel and press the bell icon to stay updated. And if you want this full code, just comment for the same. And if you have any queries or something related to Python and machine learning, you can comment down. Our expertise will reach you soon. Thank you so much for being here. Till then, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.